Hello, this is Colton Beavers. I'm going to be explaining the naming scheme behind IUPAC names and common names. To be able to identify chemicals, chemists have used two different methods to do so. These naming conventions are useful in their own separate ways, but one is more common and preferred for naming. Common names are the older of the two and more ambiguous. Generally, people don't use common names for complex molecules because if you must remember each molecule's name. But for simple molecules, they can be a great way for these molecules to name these molecules fast. Because of a lack of structure, chemists need to be familiar with the structure of the molecule prior to the conversation, like methyl ethyl ether. We can easily see that a methyl group and an ethyl group are combined by an ether group. IUPAC would name this molecule as methoxyethane. This can be confusing to some as it's a bunch of root words mashed up together, but to the initiated it's simple, because IUPAC uses a systematic approach to name molecules. One must use a set of rules to name molecules and disambiguate fringe and complex molecules. Because of the clarity, most chemists tend to use this system. Although the common naming system isn't preferred, it is still useful when naming complex substituents. Branch names are still used by many chemists because it can shorten the number of words used to describe a hydrocarbon chain. First, N describes a straight chain such as N-pentane. This is often redundant and would be just considered pentane. Although it is redundant, N conveys no bending of the hydrocarbon chain. Next, iso implies the chain branches into another chain. Down the line, it is connected to another carbon. In IUPAC terms, 3,2-methylpropyl pentane would be commonly known as 3-isobutylpentane. Then, sec alkanes are bounded by two other carbons. Next, tert alkanes are bound together by three other carbons. Cycloprefix describes a ring structure. On the next slide, it should describe when it is appropriate to use common names to describe what a molecule looks like to someone who doesn't know what a molecule looks like. It's blank. That's not right. Uh, it's blank. It shouldn't do. Oh, don't. Don't do it. Well, that's petty, but it is ambiguous to use common names for complex molecules, unless you really don't care what the molecule structure is and you just want your Tylenol. No acetaminophen. Nope. Paracetamol. Gah, toads, beetles, bats. It's confusing. Next, naming with IUPAC. First, number the longest carbon chain. Then, identify all the substituents after that. Number all the substituents such that the least number of numbers are used regardless of the substituent type. Lastly, we have to write the names of the molecules in alphabetical order, but disregarding prefixes such as di, tri, etc. Most of the time, the numbering will be out of order, but the substituents are in alphabetical order and are useful if multiple substituents are present. Here's a naming hierarchy for common substituents, and the reply should be an embedded link to an XLS, the spreadsheet. This was also taken from Chapter 1 notes. Now, let's put it all together. On the right, we have a molecule that we need to name. First, we must identify the longest carbon chain. The cyclohexyl group has the longest carbon chain, and the other substituents have less than 6. So, cyclohexane is our parent chain that we are going to build upon. Next, we must identify the substituents that we have. There is an alcohol group and an alkane group. In step 3, we need to number our molecule. Since we have a substituent chain, the numbering for it always starts in the carbon that is connected to the parent chain. Since this one is connected to the parent chain, we're always going to start from 1 here. Now we need to name. Because the alcohol group is not the parent chain, we need to use the prefix for hydroxy. Finally, we put it all together for 3-hydroxy-propyl cyclohexane. Thank you for your time, and let me know if you have any more questions. This was Colton Beavers.